Today we'll be covering Leetcode 27, remove element. Given an integer array nums and an integer val, remove all occurrences of val and nums in place. The order of the elements may be changed. Then return the number of elements in nums which are not equal to val. To solve this problem, we'll use two pointers. Pointer 1 will start at 0, and pointer 2 will also start at 0. Now a quick note on variable names. Pointer 1, pointer 2. That doesn't really tell us much. So there's a distinct possibility we'll get into the code, we'll have a bug, we'll have to debug it, and then we'll get confused what pointer 1 and pointer 2 are pointing at. So let's do ourselves a favor and give descriptive names to each of these. Pointer 1 will be our read pointer, and pointer 2 will become our write pointer. Our explanation might make a bit more sense if we swap the first two elements in our nums array. The first thing we want to check, is nums at index write pointer equal to val? If it is, then is nums at the read pointer equal to val? If it is, then find the next valid element. We will replace the element at the write pointer with the valid element at the read pointer, and then increment our write pointer by 1. We will also increment the read pointer by 1. That is the basis of our algorithm for solving this problem. Now we'll show how we're going to turn that into code. Okay, so now that we've seen a little animation that gives us a hint of the algorithm we're going to use, let's go ahead and start writing some notes here before we get to our IDE and start writing out our code. So we decided already that we want to give meaningful variable names. This will help us so much in our Leetcode journey, especially when we make mistakes. So let's start off with our write pointer, which we'll abbreviate to WP. Now, if you're just starting out and brand new, go ahead and write it all the way out. Do write pointer. There's nothing wrong with that. But for me, I'm kind of used to it at this point, so I'll just put WP because I know what that means. Okay, so we're going to write out some code. This is not optimized, but we're just going to write out how we're going to go through and check each value. So we're going to do a for loop. We'll say for read pointer in range. We're going to do the length of nums. Okay, so let's think back to what we checked. Okay, first thing we're going to check if nums at write pointer is equal to our value. So if, we'll just say n for nums at what? At our write pointer is equal to our value, then what were we going to do? Well, we need to check if we have a valid value to write there. So we're going to check our read pointer. So is nums at the read pointer equal to value? If it is, well, we need to iterate through the loop again until we find a valid value to replace this one with. So for now, once again, this is not optimized. This is just showing step by step what we're doing. We're just going to continue. All right. This will go to the next index, RP, in our iteration. Okay. So we were checking if it's equal to value, but what if it's not? We don't write if it isn't. We'll just write else. What are we going to do? Well, we're going to set nums at the write pointer equal to nums at the read pointer. Now, what do we need to do next? Think about this. Yes, we need to increment our write pointer. Now, we're going to do a very similar thing for if nums at the write pointer does not equal the value. Okay, so if it's not equal to the value, what are we going to do? Well, we need to put a value there, right? Now, there's a distinct possibility that the read pointer and the write pointer are at the same value. But let's say they're out of sync a little bit. Let's say our write pointer is at index 2, which we just overwrote. Our read pointer is like on index 7. Well, then we have to overwrite the next value. So we're going to set nums. Well, once again, we're going to check if nums at our read pointer is equal to value. Because if it is, well, we need to keep iterating until we find one that we can use. So we'll put continue. And then if that's not the case, we will set our nums at our right pointer equal to nums at our read pointer. And then we're going to increment our right pointer. And then we've altered the array in place, and they want us to return k, which is the number of elements that are valid. Now we already have a value that'll signify that. That is our right pointer, because our right pointer started at 0. Let's say all the values are invalid. Well, then it'll never move and we'll return 0. It's like, hey, every value is bad. So each time we increment the right pointer, we're saying, hey, we found a valid value. So at the very end, we've altered the array in place, and then we just need to return our right pointer. Okay, so let's go ahead and let's walk through this. Let's walk through this with a sample array, and we'll show how this is going to work. Let's go ahead and start with the example that we had earlier. So we'll say nums is equal to, and what was it? I sure don't remember. So let's do a different example. 3, 2, 2, 3, where val is 3. Okay, so let's write out our variables. We have right pointer. It's going to start at 0, and then read pointer, which also starts at 0. And that's it for our variables. So for RP in range, the length of nums, is the right pointer equal to value? Well, let's take a look. 3, yes it is. Okay, so what are we going to do? Is the right pointer equal to value? Yes it is. All right, continue. Go to the next step of the loop. So right pointer gets incremented to 1. Is our right pointer equal to value? Well, it's still pointing at 3, so yes. Is our read pointer equal to value? No, it's not. Okay, so what we're going to do is we're going to update at our right pointer to the value at our read pointer. And then we're going to increment our right pointer by 1. And so now we're done with the if statement. So we're going to go to the next iteration. So right pointer gets incremented to 2. So now our, read pointer. I've said that wrong a million times and I'm sorry. I'm sorry. Okay. So our right pointer is pointing at 2. Is 2 equal to value? No, it is not. Okay. Is the read pointer equal to value? Well, read pointer's at 2, so 0, 1, 2. No, it is not. So we are going to overwrite the value at right pointer with the value at read pointer. Now, in this instance, it just happens to be the same value. But it could have been, let's say, a 4, and we would have had to overwrite that one. So now we're going to increment our right pointer to 2. We've reached the end, so we're going to increment this to 3. So 0, 1, 2, 3. So the right pointer is pointing at 2. Is it equal to value? No, it's not. And so we go, and this is our final value. We're done with our iteration. So our new array, n equals 2, 2, 2, 3. Now remember, they only care about the first k elements. And we said that we're returning right pointer, so 1, 2. They only care about the first 2 elements. The rest of these doesn't even matter. And then we're going to return 2. That's how many elements were valid. And that's it. So let's head over to the IDE and see how we can make this code just a little bit neater. Okay, so let's do an exercise here. We're going to write out our algorithm just as we had it in our notes. And then we're going to spend some time making the code a little bit cleaner and easier to read. So first we need to set our right pointer equal to 0. Then we're going to do our for loop. So for right pointer in range, the length of nums And if you recall, we had quite a few comparisons. So first one was if nums at our right pointer is equal to val. Then we're going to check if nums at our right pointer, read pointer, is equal to val. And what did we do in this instance? Well, we just continue the iteration because we got to find a value at the read pointer that is not equal to val. So once we get there, then we're going to set nums at our right pointer equal to nums at our read pointer. And then we're going to increment the right pointer. Now, we needed to check the else statement here. So if nums at the right pointer is not equal to value, well, we're going to do a very similar thing. Actually, we're going to do the exact same thing. We're going to check if nums at the right pointer is equal to value. Sorry, I copied too much. We're going to check if nums at the read pointer is equal to value. And then we're going to wait until we get a valid value to write. And then lastly, we would return our right pointer. Now let's see if Leetcode likes this. And it does. Although the code, I don't like it. It's not very pretty. So let's see what we can do to clean this up just a little bit. If we notice here, we're checking if the right pointer equals the value. And then here, if nums at RP equals the value, we don't do anything. Well, so what we're really looking for is if nums at the read pointer is not the value. So we can just combine those two statements with the logical and. And then we can do the same thing down here. Instead of else, we'll say else if. So nums at the right pointer is not equal to value. And I just noticed I put an if here instead of an and. And same thing here. Nums at the read pointer is not equal to value. Then we go ahead and run this. Now let's run and see if Leetcode likes it. It does. Now you're going to notice something else. Each one of these has nums at right pointer is not equal to val. So we can compress this even further. We can get rid of this else statement. And then we can just say if nums at our read pointer is not equal to value, then we update nums at our right pointer and increment our right pointer. And then we return a right pointer. Let's run, submit. Leetcode is happy. Big O of n, time complexity. And we don't have any data structures, so what do we got here? Constant space. So there you have it. That is remove element.